and otherwise we can adjoin. But if we adjoin it, we have to define operations like this: x into 1 is equal to x is equal to 1 into x for every x belongs to S, and 1 into 1 is equal to 1. So if semigroup S does not contain this identity, we can adjoin, but we have to define operation like this: x into 1 should be equal to x equal to 1 to x for every x belongs to S. S is a semigroup here, and 1 into 1 we have to define is equal to 1. So dually we can define a semigroup with 0 element. All of you can note down. You can note down from here the definition here. Now just I am making change in the same, that is semigroup with 0 element. Semigroup S with at least 2 elements containing element denoted by 0, such that x into 0 is equal to 0 is equal to 0 into x for every x belongs to S. This is called semigroup with 0 element. You can write this semigroup with 0. Now, if semigroup does not contain a 0 element, then we again adjoin 0 element, and we denote it by like this: S0, and this is semigroup with 0. This is equal to S if S contains 0, and this is equal to S union 0, otherwise we can adjoin it. But when we adjoin, we have to define operation like this: x into 0 is equal to 0 is equal to 0 into x for every x belongs to S, and 0 into 0 is equal to 0. Is it clear? So this is the semigroup with 0 element. Now I tell you the important fact. You just can copy from here. Important fact is that a semigroup can have at most one identity element and at most one 0 element. Now I leave this to prove this fact, to verify this fact. I leave for all of you as an assignment. So students, you have to do this as an assignment. You have to prove that a semigroup can have at most one identity element and at most one zero element. It means what? It means that it may be possible that a semigroup S does not contain an identity. It may be possible that semigroup does not contain a zero element. But if it has, then it must be unique. You have to prove that identity exists in semigroup. If it exists, then it is unique. No semigroup can have two identities. No semigroup can have two zeros. So you have to verify this. I left for all of you, and I hope that all of you can do. And if you can't do any assignment which I left for all of you, if you can't do, you can just query me. You can just ask me. You can just discuss me. No problem. Anyway, so next semigroup is that. Also, if you want, yes, the examples of the trivial, you can just search out of yourself what are the examples of semigroup with identity and semigroup with zero element, isn't it? But if I say that, then if you search about the example that which contains identity element as well as zero element, both. A semigroup which contains an identity element also and which also contains zero element. So this is one example is given in this. You can just see very easy example that if you choose the interval I from 0 to 1, closed interval it is, and now you define operation of this as x y is equal to minimum of x y, where x comma y belongs to this closed interval this. Now you can search out what is xy is what, operation is what, defined as minimum of xy. So well you can see well that what is does it contain zero element? If it contains, then what is the zero? Does it contains any? You have to verify that with respect to this operation it forms a semigroup or not. First thing. With respect to operation defined this, does identity exist? Does zero element exist? If identity and element and zero element exist, then what are those? So you can see that here one is the identity element and zero is the zero element. Can you see? You can just verify by yourself. Semigroup with zero element, zero and identity element 1. You can verify. Now next type of semigroup is commutative semigroup. Now semigroup S is said to be commutative if xy is equal to yx for every xy belongs to x. So you can search of your own what is the example of the commutative semigroup. There are many examples of commutative semigroups. Also, there is a trivial semigroup. That is semigroup which contains only element 1. E. Here operation is defined like this. E star E is equal to E. This is a trivial semigroup. Here E is a zero element. Here E is a identity element. Now next example is null semigroup. Null semigroup, S be a semigroup such that S square is equal to 0. That is, AB is equal to 0 for every that S be a semigroup with 0 such that S square is equal to 0. That is, AB is equal to 0 for every AB belongs to S. Then S is called null semigroup. So in null semigroup, what happens that if you any product of any two elements, product means that product means not usual product here. The operation is always in between A and B. Operation is binary with respect to which S forms semigroup. So product of you just for simplicity we just say like this, that the product of any two elements will be 0. So first you have to take a semigroup with 0 such that S square is equal to 0, then that is AB is equal to 0 for every belongs to C. Then S is called null semigroup. What is the example? Yes, you can construct by yourself the example. That is, if you, for example, if you define like this 0 A B 0 A B 0 0 0 0 0 0 0 0 0 0, just define like this. Now you can see that with respect to this operation star, this is the table. I have defined a multiplication table or binary operation table. So see, you can see well that with respect to this operation, it forms a null semigroup. Product of any two elements